Okay, we're here at go-to-math.com. Click on the calculus, go down to average value, the average value theorem, I think is what that should say. What are we doing? This one here? Okay. I mean, it's like you do one of these, you've done them all, you know? Anyway, find the average value of f of x. So this is not a straight line like the last problem. Now you're like going, wait a minute, wasn't this like the same problems, same functions, even their names are the same? Uh, is the mean value theorem? We did the mean value. Well, they are. It is. You know, we don't want to make too drastic of a change, scare everybody to death, right? Okay, what are we doing? Let's go back to the whiteboard. Anyway, I didn't write this out last time. Let me go ahead and write this out. 1 b minus a, the integral a to b, f of x, dx, right? The average value. Average value. And so our f of x, I guess I could write bigger, couldn't I? F of x is 7x squared. And we're in the interval between 1 and 5. 1 and 5, okay? So what the heck? Draw a picture, you know what I'm saying? Probably not. Draw a picture. Here we go. There's our picture. We'll say this is 1 and this is 5. And don't hold me to it because this may not be to scale. Anyway, what's really going on here is we're taking each one of these y values and we're adding them up. You're like, man, wait a minute, that adds to infinity if you took every single, well, you couldn't take all of them. This is infinitely dense, the real number system. Never mind, that's topic for another day. Anyway, if you took them all and added them all up, all the y values, in other words, you picked a number real close to 1, real close within a delta or something, and then plugged it in and got your first y value. We'll say the first one we did was just plugged in x of 1. And then we did f of x of 2, and we plugged in another number. Like, for example, 1.1, 1.2, 1.3, 1.4. Of course, you know, we're using calculus. That means it's closer than 1.1. It's like 1.00000000000000000. Stop. 1 plus 1.00000. Anyway, get the idea. That's the power of calculus, right? We got time. What do you think? We got all day to do that stuff? F of x of n, and let n go to infinity, divided by infinity. No, you wouldn't do that. But anyway, divided by n. I mean, if you did this like 1,000, there were 1,000 of these, you'd get pretty close. Okay. Well, anyway, that's what's going on here. And my guess is, let's guess on this one. What do you think? Right in here somewhere? The average. I don't know. I think it's close to 4 maybe. We'll say 4 is right here. I'm not, no, wait a minute. And never mind. Let's actually figure this out. So 1 over 5 minus 1, take the integral, 1 to 5, 7x squared dx. I remember a long time ago, actually I don't think it was too long ago, I actually started to understand this stuff, and that's how I did it. I actually picked some numbers. I'm like, wait a minute, this value's, and I did this, and I said, why is this value getting closer and closer to this number here the more of these I do? And then I finally understood what was going on. It's amazing stuff. And you know, that's how you really learn math, is you just got to kind of experiment. Don't be afraid of it. Experiment with it, you know. You got to just experiment. Go out on your own and experiment. And I tell you what, if you haven't learned a programming language yet, you should really do that. I highly suggest it. 4 times 3 is 12. Because you can really understand this stuff, I think. What did I do? 3 times 4 is 12. A whole lot better if you write a program to actually approximate this answer. Um, when I get a chance, I'm going to do some tutorials on each one of these calculus sections on doing such a thing. See, I'm sitting here talking, and that's how I screw things up. Okay, and so what do we got here? Let's plug this into the old calculator. I'm going to, yeah, I think you really better understand what you're doing, especially in this calculus. By writing programs actually produces the actual answer. Now, of course, you just focus on it being an approximation. You don't want to focus on it being an exact value. Let me tell you, that's a whole different story there. Now, I'm getting 217. I mean, you learn a whole lot more of your algebra, I guess, when you do that. I get 217 over 3, and I can't remember, but find the average. I guess it's the exact number, yeah. So I had to write a function that simplified fractions, and you learn a whole lot about fractions when you do that. So I get 217 over 3. Now, actually, in the very beginning of this tutorial, we were guessing on what the heck this would be, and I can't believe I wrote a 4 there. I'm not exactly sure what I was thinking because these are y values. And I'm getting 72.33 something in the decimal form. And if we plugged 4 into this thing, let's see, 4 squared is 16, 16, what is 16 times? We're just doing this for fun, right? 16 times 7. Have I lost my mind already? 16 is 42, so 112. Like, what the heck is going on? That's 42, so yeah, 112. Yeah, 4, you plug in 4 and you get 112, which is way the heck up here. So I guess it's between 3 and 412. 3 squared is 9, that would be 63. Yeah, so it's somewhere between 3 and 4 that C is at. Remember the C back in the mean value theorem? Right, don't want to forget these things. Anyway, come on over. We're at gotomath.com having some fun, right? Come on over, practice. No, I might